Have you ever stopped to wonder what the absolute toughest life form on our planet is? And I'm not talking about something that can just, handle a tough winter. We're talking about life that actually thrives in places that seem completely alien to us. Places like boiling hot springs, the crushing pressure of the deep ocean, or even the vacuum of space. So let's get into it.
This really brings up a massive question, one that goes way beyond just biology. It really pushes the boundaries of what we even think is possible. Where's that absolute line in the sand where life just stops? Well, it turns out the answer is way more extreme than you could probably ever imagine.
Okay, just take a look at these numbers. They are absolutely wild. We're talking about life thriving at 122 degrees Celsius. That's not just hot. That's hotter than boiling water. And the pressure? 1100 bar. To put that in perspective, that's over 1,000 times the air pressure you're feeling right now. And the radiation some microbes can handle? It's thousands of times what would be instantly lethal to us. And remember, these aren't just theories. This is what's actually been found and documented right here on Earth.
So what do we call these incredible organisms? Well, they have the perfect name, extremophiles. And the most important word there isn't survive, it's thrive. Coming from the Greek for love of the extreme, these creatures aren't just barely hanging on. For them, these intense, hostile environments are, well, their home. And you can find them in all the places we used to think were completely lifeless. We found them in bubbling volcanic springs, clustered around hydrothermal vents in total darkness deep in the ocean, and, get this, even miles below the seafloor, living inside solid rock. They're a fundamental, if mostly invisible, part of our world.
So the big question is, how do they do it? What's their secret? How do they survive conditions that seem completely unsurvivable? The answer is a truly remarkable biological state that honestly sounds like it was ripped straight out of a science fiction movie.
It's called cryptobiosis, and the easiest way to think of it is just pure, real-life suspended animation. When things get really bad, these organisms can literally hit the pause button on life itself. And I mean a full pause. All measurable signs of life, metabolism, growth, repair, they all just grind to a halt. They just wait. If we're going to talk about cryptobiosis, well, we have to talk about the undisputed, hands-down world champion. It's a microscopic marvel you've probably heard of. It's often called the water bear, the tardigrade. These stats just show how ridiculously good they are at this. When a tardigrade enters this state, its metabolism can drop to less than 1/100th of a percent of normal. Its body can lose up to 99% of its water, basically shriveling up into a tiny, nearly indestructible speck called a ton. And in that state, it can handle almost anything you throw at it. Here's the really cool part. Cryptobiosis isn't just one single magic trick. It's more like an entire toolkit of survival strategies, with a different tool for every single kind of disaster you can think of. There are 5 known forms, and each one is basically a different superpower. You've got anhydrobiosis, for when there's no water. Anoxybiosis is for surviving without any oxygen. Chemobiosis is the defense against high levels of toxins. Cryobiosis lets them survive a deep freeze, literally being encased in ice. And osmobiosis kicks in when the water around them gets incredibly salty. And the tardigrade, you guessed it, it's the only creature we know of that has mastered all 5. Okay, so this is all really fascinating, right? But you might be thinking, why does any of this matter to me? Well, it turns out it matters a lot. Understanding these natural superpowers is actually opening the door to some truly world-changing technologies. Let's just focus on one of those superpowers for a second, anhydrobiosis. Again, from the Greek, for life without water. It's this incredible ability for an organism to completely dry out and then, later, with just a little bit of water, come right back to life as if nothing ever happened. Now think about what that really means. We're not just talking about surviving for a few days or weeks. As this quote from the source material points out, some of these organisms can survive for decades, maybe even centuries in that dry state. It's a level of natural preservation that almost seems impossible. So, what if we could copy that trick? What if we could use nature's own preservation method on something else? Something really important and fragile, like, say, a vaccine. And that is exactly what's happening. Researchers are literally borrowing the secrets of anhydrobiosis to create dry vaccines. Now, this is a total game changer because it would get rid of the need for the cold chain, that constant, expensive refrigeration that's needed to get vaccines to remote places. This technology could make life-saving medicine accessible to millions more people all over the world. But the impact of these tiny survivors doesn't stop there.
Their unbelievable resilience is forcing us to rethink what might be possible far, far beyond Earth.
For astrobiologists, the scientists looking for life in space, extremophiles are basically the ultimate guide. They show us that life can exist in conditions we used to think were completely sterile. So when we search for life on Mars or on the moons of Jupiter, we're not just looking for perfect Earth-like conditions anymore. We're looking for those extreme environments where something tough, something like an extremophile, might be thriving right now. And all of this leaves us with one final, pretty mind-bending thought. We now know that life, at its core, is just unbelievably tough and persistent. So if it can cling to existence in the most hostile, unforgiving corners of our own world, what does that really mean for the chances of finding it somewhere else out there?